Okay, so welcome to this very short, hopefully, presentation about the state of Lightning Network. I am Christian Decker. I used to actually live in Lugano, so it's really nice that that my child's town and my hobby / full-time job now sort of merge. Never expected that to happen, so definitely a good surprise. I am, like I said, I'm a Lugano native, so to speak. I did my PhD on scaling and securing Bitcoin. And one of the end results of that PhD was actually a similar system to Lightning, let's say like that. And after my PhD, I decided to join the Lightning Network effort and essentially help out and create a global borderless payment system that would be able to compete with existing payment system that might be more centralized and might be less anonymous. So what am I doing today, and why am I actually talking to you guys today is because I'm still involved after all of these years. I still write the specification with other teams. So my team from Blockstream, there is a team from Lightning Labs, there is a team from Paris, Eclair, and there's now a fourth team called LDK by a good friend of mine, Matt Corallo. So that's always been nice. Today I will be talking about the state of the Lightning Network, more specifically from a specification point of view. So I hope you're not waiting for hockey stick graphs of the network balance going up to the sky. This is a more technical talk, despite people having been told that I am not allowed to go too technical. So it's weird in between, so bear with me. Okay. So the Lightning Network. Who here is running a node, by the way? You're all going to be bored. No. But in that case, you probably all know what the Lightning Network is for, right? But you might not know what our focus is as a specification. The Lightning Network, as it was written in the paper itself by Joseph and Taj, is a decentralized system whereby transactions are sent over a network of micropayment channels, aka payment channels, or transaction channels, whose transfer of value occurs off-chain. That is quite a mouthful, and not at all descriptive of what we actually want to achieve, right? So what we really want to do, and what we as a specification are concentrating on, are sort of these three pillars of the Lightning specification. Of course, the one that everybody will have mentioned is scalability, of course. The scalability of Bitcoin is rather limited. We can have about 7 transactions per second, depending on type of transactions. And we have confirmation only after an expected time of 10 minutes. So try going to the grocery store and buy something and then pay with Bitcoin, and you'll be waiting quite a while at the point of sale. Even worse if you want to buy a coffee, by the way. That's going to be cold by the time you're getting to drink it. On the other hand, if we build a Lightning Network made up of channels where we have two-party contracts between the two of us, and we can just adjust the balances of these channels arbitrarily quickly, there is actually no limit to how quickly you can move funds back and forth. Well, there's one limit, it's the speed of light, but that's kind of high, so we don't care that much about that kind of limit. We can also just add capacity to the network by adding more participants, by adding new channels. The limit on updates is essentially per channel now. So what we measured in a highly non-scientific way, and by cheating quite a bit, we got about 500 transactions per second. I'm sure we can double that, if not triple that, quite easily by taking a look and optimizing some of the parameters. But one thing that this also allows you to do is do real-time payments, right? Now you can actually get a piping hot coffee and pay with Bitcoin, and not have to wait for the payment to be settled. The second pillar for us is the privacy. Bitcoin as a payment system, essentially every interaction you have with the Bitcoin blockchain leaves a permanent, indelible trace. And even if it doesn't look like you're getting profiled today, because, well, that's just random information. Who knows? Maybe in the future somebody comes back with a new insight and is able to actually create really detailed profiles about yourself. So what we do in Lightning is essentially, instead of using a global medium to transfer funds, we use these 2 of 2 off-chain contracts where we can do transfers, and we then chain them together to essentially reach our actual destination. It's very much like a modern ISP's work, by the way. If you want to connect to if you want to talk to Facebook or Google, not that anybody wants to talk to Facebook nowadays anymore. You're not drawing a cable from your computer to a Facebook server, right? You're talking to Sunrise or Swisscom, and they, on their term, will then forward that request to somebody else until eventually it reaches some server in the US and that actually has the information you want. What ends up on-chain are just summaries of the interactions we had in between, so it's far more difficult to say that, oh, there's $5 that changed hand. Was that 5 million small payments, or is it one big payment and some refund amount that we got back? So the amount of obfuscation we can add by going off-chain is quite a bit. And particularly exciting for me is the permissionless innovation. That's definitely something that nobody thinks when talking Lightning, but for protocol developers, this is actually cool. I've tried for several years to implement something in Bitcoin Core, but Bitcoin Core is a global shared medium, right? We all have to agree on exactly what A means if we write A somewhere. On the other hand, in these off-chain contracts, what we can do is essentially, as long as you and I agree on what the rules are and how we want to just change our state, we can do it. There is no need for everybody to opt in, and we can therefore quickly iterate on ideas and do work. It's also voluntary for anybody to join the network. So that's also very much in line with our ethical views. Okay. So, of course, every good story has a beginning. This one is kind of weird. Just by show of hands, what's the first ever time that you think something like a payment channel came up? Was it 2015 with the publication of the paper? Was it slightly earlier? Was it a lot earlier? Any guesses here?
I would expect a lot earlier.
A lot earlier. And you might be right, you can't actually go any earlier. So Satoshi had, in his very first code, he had this idea of using a sequence number to be able to say essentially, oh, I have version 1. And before that's confirmed, I will issue version 2 of that transaction, and a miner who sees that is then supposed to essentially replace that old transaction. So what we can do with that is we can have $10 here, I send $1 forward and $9 back to me, and then I notice, oh, but I actually want to do another incremental payment, so I create a new transaction where I now send $2 to my counterparty and 8 back to me, and only one of them will confirm, and the latter one will be the one that is chosen. So we can do really quick updates on things. Problem is, this is ultimately totally broken. There is no way to guarantee that miners will see the second transaction in time. There is no guarantee that the miner will actually adhere to this protocol, especially if we can bribe a miner. We can essentially have the sender say, hey, I know I'm out $10, but you get 5 if you confirm my version, and I get 5 back. So this never worked really as planned, but it's a nice sort of find that even Satoshi in his very first version had this code in there. So how do these off-chain contracts work? And by the way, this is we're talking Lightning, but a lot of constructions are very similar to this. And I promise this is the last technical slide for today. See, I can't do non-technical talks. So what we have in the end is we have a number of participants on the left-hand side. We have the data in the blockchain, essentially associating a name or alias with a value that they own, and we start off with the situation. So our first step in all of this is, well, we need to lock up some funds, right? What we do here is that Alice and Bob are creating what's called a multisig address. That's an address where both Alice and Bob have to sign, hey, this transaction is valid. We both agreed on what happened with these funds, right? That way we can essentially just prevent one side pulling the funds away underneath our negotiation, right? It's all fine and good that we negotiated thousands of times a second that, oh, you get a cent more, I get a cent more, you get a cent more. But if one party just pulls the fund out of underneath us, then all of that negotiation isn't worth much. So we create a multisig address and send some funds on there. And now we go into separate room. So from now on, we don't talk to the blockchain anymore. But what we do is essentially we take that initial state. So Alice and Bob both have added 5 Bitcoins into this on-chain contract. And now we go into a small separate room and we start negotiating. How do we split up these funds, right? And of course, because both parties added 5 Bitcoins initially, well, the final settlement is going to be 5 to Alice and 5 to Bob. That's all fine and good, but we want to do updates, right? So that's as easy as just creating a new transaction, spending those funds and splitting up the funds in such a way that we get this new state. So effectively what we just did here is transfer 1 Bitcoin from Alice to Bob, as reflected in the total balances in this contract. And of course we can do that a number of times. We can even send funds back. So that didn't used to be the case always. There was a thing called a simplex micropayment channel where you could only transfer in one direction. And ultimately, when it's time for us to say, hey, I don't want to talk to you anymore, I just want to take my funds and go, well, we send it back to the blockchain. After all, we represent our state as a transaction, and we can then apply that transaction to the blockchain. And what we do is we now unlock these funds with a new allocation. So Alice gets her 6 Bitcoins back, that from the initial 5, and we netted 1 transfer from Bob to Alice. And we can go our merry way. No need to continue interacting. So this is the opt-in where people can choose to interact with a party, go negotiate something, but they always have the option of eventually pulling out those funds. Excellent. So, of course, we won't start quite at Satoshi Nakamoto 2009. I guess the first time anybody has heard about Lightning is through the paper by Taj and Joseph. So in 2015, these 2 gentlemen published a paper that was the first paper to introduce a way where we could not only send funds in one direction, but we could actually send it back and forth. It was really complicated, and I was annoyed because I had a paper in review for a conference that was competing with this, which was much simpler, of course, but they were first to publish, so I had to swallow that pill. But essentially, this is the paper that started the entire story of the Lightning Network, and so we shall start here too. So what happened in the beginning, right? 2015, people started reading that paper. In 2015, my current colleague Rusty Russell started looking into how we could actually implement this, because papers, some people might know, are really abstract and don't have all the details you need to actually get stuff to work. So what do we do to get it working? Well, you build a system that implements it. That's exactly what Rusty tried to do. I joined 6 months later, and the core Lightning team was born under the guide of Blockstream. And a couple of months later, Lightning Labs was born, funded by Taj and Joseph themselves. So they definitely had the brand recognition there. We tinkered for a while, and in 2016, in late 2016, we met in Milan and had the first spec effort, so to speak. So after a bit of experimentation, where everybody sort of just tried random stuff and was experimental, and we were basically hippies high on coke and trying everything, a single idea that crossed our minds. In 2016, it was time to grow up. And we met in Milan and decided, hey, it's no good to have 3 different implementations of the Lightning Network, none of which works with the other one. Shall we maybe create a unique global network that we can all use and essentially multiply the utility we get from such a network? So 2016, we created a specification effort, and it took us over a year to actually get to a state where anything was usable at all. 2018 came around, and suddenly everybody was reckless. So Blockstream opened a sticker store, which is still active today. Well, we're starting to sell a bit bigger items too. So if you ever wanted a satellite dish, we have some, for whatever reason. But in order to sort of steer the enthusiasm of the community, which was, by the way, amazing, and we were afraid people would put in their life savings into code that had more than 1 year of age. So we started labeling efforts to use Lightning as reckless. Essentially, a big warning sticker in front of Lightning, so that people wouldn't put their life savings in there. We also did a bit of trickery. Anybody remember the channel size limit? That was us being afraid that you might actually lose huge amounts of money. So we did a bit of trickery and actually moved from Satoshis to millisatoshis to essentially say, hey, yeah, you can't put more money in because numbers only go that high. Yeah, and we still have millisatoshis, so that's kind of neat. You actually can send a millionth of a dollar worth of a payment right now, which enables a whole slew of different applications again. 2018, we also had the first mainnet releases, so LND, Core Lightning, Eclair, and Ptarmigan, a company that hasn't been contributing lately. We all released our clients, and you could actually start playing around with Lightning, and boy, did people come. So that was definitely interesting. We also had our first couple of attacks. So there was a denial of service attack in 2018 that for some reason didn't help much. Well, it didn't disrupt our services at all. That's the power of decentralized networks, is that if you take down one component, well, we just start routing around that. We also started doing hack days and actually meeting with the community and getting feedback, which is very welcome, by the way. If anybody has feedback on the workings of Lightning, we might have to say that it's a known problem and we don't have a good solution, but it's always good to see that people are testing this out and rediscovering things that we might have very deep on our task list somewhere. And of course, we had the second Lightning specification meeting in Adelaide, which sort of laid out what went well and what didn't go well. where there was chances of improving the situation, and how we would tackle open issues. And we'll get back to open issues because we still have quite a few open issues. I'm sure everybody knows that. So 2019, and that was a bit quick. Okay. We have new features being released. Very quick release cycles. I decided to point out the Lightning Torch event, which was huge. We even had people sending Lightning transactions from planes to other planes. Still don't know how that worked, but hey, apparently it did work. And of course, we are starting to see integration. So I used to have the W3C committee for web payments in here, of which I was a member, but that was sort of dropped over time. But we got beer. So Lightning beer, people were really surprised how quick Lightning payments were. You couldn't have the cup underneath it in time before it actually started pouring. So you'd actually have to put the cup underneath it, then scan the QR code. Otherwise, you'd lose half of your beer. Even I wasn't expecting that one. And of course, we had the Lightning Network conference where I presented a first state of the Lightning Network presentation. Back then, it looked like this. So the Lightning Network is composed of these nodes highlighted in white and channels in yellow. We used to have 1,700 nodes and 6,500 channels and about 20 bitcoins. And you will definitely notice the question marks there. That's a question we get very often about the Lightning Network. So how much are people actually transferring over it? And well, that's one downside of building in privacy. You never know how successful or unsuccessful you are. So we just assume we are successful and keep on going, right? But so far, we haven't seen major breaks in the privacy preserving techniques that we are using. So where are we today? Well, obviously, I have to show this picture updated again. I had to turn down the brightness of the lines, by the way. This thing would have been pretty much yellow on the upper half if I hadn't turned down the brightness. But you can essentially see we have 3 times as many nodes, no, 10 times as many nodes and 10 times as many channels. And quite a few bitcoins. So that's a 25x on the amount of bitcoins we have in there, and still no transaction knowledge and no fees. So maybe privacy is working here.
Is that including the Tor nodes, or are they missing?
These are only the nodes for which I had IP addresses, because I use IP addresses to map those. So no, actually the real network is about half of this larger even. So No. So these are public nodes that have an IP address. I excluded public nodes that didn't have IP addresses, but we know from analyzing the blockchain that there are about 40% of the network that are not being announced at the moment. And we do that by essentially looking for traces of channel opens and channel closes on the blockchain. So add 2/3 of the numbers here, and you're in the right ballpark for the actual network size. The exact network size, we don't know. It's between 2 parties, so unless they start sharing the information about what they're doing, we will never learn about it. And as a big numbers and measurements guy from academia, that's really annoying to me. But, well.
But it's better for us.
It's definitely better for you guys, yeah. I just would like to see some numbers telling us how successful we are. You know, number go up.
5,000
Yeah, it's a good proxy, I guess. So yeah. Oh, by the way, just shout out questions. I love interactive talks. So and I know I can ramble on for quite a while, so feel free to interrupt me at any time. So this is what we were what we are today. Now, of course, the network is far from finished, right? We do have quite a few issues to tackle. So let's see how we are doing with scalability, with the 3 points at the beginning. Scalability, well, we get 500 channels per transactions per channel. So that is one stat that sort of points towards the scalability goal being reached, but that is only across one channel, right? To perform a payment in the Lightning Network, we actually have to use channels that are remote from us, find a path through the street map of the Lightning Network city. And often these paths are congested, right? There is insufficient capacity. You can't actually send a payment through a channel of a certain size. So what do you do now? Do you start splitting a payment into multiple chunks? Now there can be partial payments that succeed, and so on and so forth. So scalability, yeah, we got quicker. Real-time payments are now a thing, but the success rate of payments is currently about 95%. So 1 in 20 payments you actually have to retry, or you might not even be able to complete at all. And that's not a nice place to be in. How about privacy? We are still communicating a lot of information about the network. In order for us to find a path through the map of the Lightning Network, we actually have to know what the map looks like. So we are actually sharing among ourselves who has a channel with whom, and how large it is, and what amount of fees are required to forward through the channel. And this information not only grows, and it takes time for you to actually synchronize with that and learn about the small little streets that you might be able to take to do your payments. But you're also leaking a lot of information. So for example, currently you leak the on-chain funds on the blockchain, and you are giving out a node ID, which is essentially an alias for you as a person, right? And so you are associating certain Bitcoin funds with your pseudo identity, and many people then use stuff like an alias to actually say, hey, this is Christian's node and I have 15,000 Bitcoins on it. It's actually a pretty bad idea to do that, I know, because I had like 9,000 Bitcoins stolen. So we should definitely do something to obfuscate more where these funds come from, or at least if we aren't interacting directly with a peer, we shouldn't care where the funds are exactly on the chain. It should be sufficient for us to know that there are these capacities we could use. On the final point of permissionless innovation, I think we're doing good. It's really hard to keep up with the development of Lightning, and that's thanks to the ability of iterating quickly. So while it's frustrating sometimes not to be able to follow a certain discussion because, well, there's people out in the weeds essentially doing nothing else for 24/7, it is testament to the experimental nature of Lightning, but also the ability for us to improve quickly. Yeah. So the specification is about 20 people. It used to be 8 back in the days, but in the meantime, quite a few companies have started contributing full-time engineers to not only the implementation, but also the specification. So the next tier up is we have about 100 engineers that are working full-time on the actual Lightning implementations in various companies. And of course, there is a huge cloud of people that we don't really have numbers for, that are independently contributing clients, web UIs, points of sale, all the stuff that actually makes it interesting for non-geeks like me, right? I like my protocols, which is why I'm talking about protocols here. But I guess most people are in it for the ability to do payments and to build cool stuff on it. And I just lack the imagination. So it's up to you guys to actually do cool stuff here. So now that we know about the issues that we have, yep.
It's pretty complex to set up and run a Lightning Network node. At least for me, it's complex. Do you think that this barrier to entry will decrease over time, and even non-technical guys will be able to set up and run a node, and how long it will take to reach that point?
Oh, the how long answer is easy. That's a running joke. It's 2 weeks. Whenever we don't know about how long it will actually take, it's 2 weeks. Easy. No, but I totally share your view that operating a Lightning node at the moment is way too hard. That is due certainly in part due to the complexity of Lightning itself, and we are working on simplifying how Lightning works itself, because that complexity then somehow then leaks into the user experience as well, and we currently pretty much require to have users that have a intricate understanding of the inner workings for it to become safe. It doesn't help that we are not able to actually provide good defaults at the moment, because we still simply don't have that operational experience either. So as we simplify and as we learn how to configure these nodes correctly on behalf of the user, it should get easier. That being said, and I have the last slide on this, is we now have a variety of potential deployments that we could perform. So in the beginning, it was very much here's a piece of software, you install it, you run it, don't come back. We now are moving into models where the nodes are either bundled with applications themselves, and the applications take on a lot of the management effort, or you might be using a custodial service, and that is okay too, right? If you are aware of the security risks of a custodial wallet and you trust the custodian, then why not? I mean, you don't want every baker in the country to have to learn about channels and liquidity management and stuff like that just to be able to perform payments, right? But we are always running to sort of improve the usability of more self-sovereign setups, in a way to match the experience of simpler, maybe more trusted setups as well. And I am actually working on a system called Greenlight, where we run the nodes and you are still in control of the keys, which is a setup where we split up the responsibility. We run infrastructure, you guys are running funds essentially. But maybe more on this later. It definitely is a known problem and something that we are actively working on, and hopefully we will incrementally make it better. Probably there will not be a moment where you can say, okay, now it's easy, right? Everybody will slowly move into that situation. Okay. So, upcoming features that we have is and to address some of these problems. Splice in and splice out is a system that allows you to have a unique number on your app that summarizes your on-chain and off-chain funds. Right now, we sort of split them out, right? You have some channels with a certain capacity, and then you have and then maybe you want to do an on-chain payment. Well, you can't because funds are in the channel. Splicing actually allows you to use the funds you have in a channel to quickly close and reopen the channel without any downtime. And while you're closing and reopening, you can move funds out or move new funds in. So you actually can resize channels at a minimal cost using these splices. And Anybody ever wondered how you can pay somebody who isn't online at the moment? The offline payments kind of issue that gets touted everywhere. So one of the proposals that we have is asynchronous payments, where essentially if the recipient is offline, we simply deposit a message saying, hey, we try to, essentially it's a postman delivering a note saying, hey, we tried to deliver a payment to you. You weren't home. Please contact us when you're back home. And when you then answer to this notice, you can actually perform the payment at that point instead of when it was actually tried. From a user experience, this is much better than the current offline, no chance of getting it done, or even calling up your buddy and saying, hey, turn on the app, I want to send you something, right? And from a user perspective, this looks exactly like as if the payment was received while they were offline. Keeping with the topic of payment improvements, there is Bolt 12, which is a mechanism for us to negotiate, very much like asynchronous payments, negotiate details of a payment on demand. So what you can do is essentially you can have something like a recurring payment, right? If you have a recurring payment with credit cards, they will pull funds from your card once a month, right? And it's really sad to see Spotify and Google, and it's a whole list on my credit card, and I hate it. But you keep forgetting to unsubscribe, right? Because, well, a pain is only once a month. In Lightning, payments are push-based, so it's the wallet of me as a user who knows that at the end of the month I am supposed to send a payment. And so what we do here is at the end of the month, my wallet reaches out to the destination, says, hey, this is I'd like to pay for the subscription of Christian for October. Please give me an invoice. And you get an invoice back. So this kind of interaction where you can defer payments, where you can negotiate details of a payment, maybe even negotiate an exchange rate for your payment, right? My invoice might be denominated in US dollars, but I want to pay in Bitcoin. So all of this can work. Payment decorrelation is a bit down the weeds, but essentially what you do now is if you do a large payment, it gets split up into different parts. Problem is those parts all have the same content essentially. So if you see one part coming in from left and one part coming in from right, you can essentially say, oh, that's parts of the same payment. Maybe I should associate a timestamp with them and maybe look for other occurrences of this information, and I might be able to know who sent this and where it went. With payment decorrelation, this information is now randomized again, such that you cannot collate that information any longer. And I probably have to speed up a bit. Multi-party channels and channel factories is a relatively old idea, but currently Lightning channels are two-party channels, right? I can only send funds to my channel partners, nobody else. And the idea of multi-party channels is essentially that we as a whole group in here, we could all pool our funds, and we could freely move those funds between to any of these users without ever touching the channel, without ever touching the chain, and without having to go through intermediaries, right? The way we used multiple channels. We can have all of these changes just in our local group. Lower on-chain footprint with Taproot and Music. That's a neat little detail. Should increase our efficiency and reduce our on-chain footprint. And optimized pathfinding, for example, is also something that we're working on. Like I mentioned before, about 95% of payments are successful. What we want is 100%. What we might be able to get with stuff like the minimum cost flow algorithm is that we could get up to 99 to 99.9% success rate. So that's one payment in 100 to one payment in 1,000 that you'd have to retry. That's kind of nice. And finally, some gossip improvements that are enabled by some of this. Now we come to the part that I was alluding to before, is essentially running a Lightning node is really freaking hard. I'm having problems running my Lightning node in a way that it actually is efficient and I can use it to send and receive payments.
You can send the setup later.
Hmm?
You can send the setup later. You can send us the setup.
Oh, yeah.
Node later.
Well, I'm not sure you want to copy my node at the moment. It's not very well maintained. But the idea is that we have a whole spectrum of different ways where how users can interact with the Lightning Network. Starting of course with probably the easiest to use, but also the one that we'd like to discourage as much as possible, the custodial nodes. So these are operators that essentially have built up an accounting system on top of their unique node, and you're trusting them to actually do that bookkeeping correctly. So probably best user experience because you don't have to manage anything. Probably the highest trust requirements too. Probably the worst privacy, but that's sort of the golden standard when it comes to user experience. And with all of the other things, we are trying to get as close as possible to that user experience and abstract away as many of the underlying details as possible. So hosted channels, for example, is a system where just like custodial nodes, you are trusting somebody to operate a real node, and then you have pretend channels with that node. The advantage over custodial nodes is that you actually have proof if the custodian misbehaved. You can essentially go to a judge and say, hey, he promised me I had $100 on my channel. Now I have only 95. That's not what I signed up for, right? So more auditing, more control, more remediation steps essentially. Then we have the hosted non-custodial providers, which is something that I am working on. Like I said, it is essentially a Lightning node as a service. But we run the infrastructure for you guys, including backups, which is a whole different topic. Oh, I should have mentioned that in iShiz, by the way. We run the infrastructure as in the Bitcoin Core node that is backing the Lightning node itself, databases, watchtowers, routing servers, and so on and so forth. And what you get on your application is essentially just a remote control for your node. So you can have as many applications as you want that talk to this remote node, and we also place a signer on your application itself, such that whenever the node being operated by us proposes a change to a state, the signer actually gets a request to sign something, independently verifies that yes, this was actually initiated by an authenticated user, and the changes match the commands that the user intended to initiate. So that way, we never have access to your funds, and you still get the sort of the App Store experience of downloading an app and being ready to go. And of course, the solution that we encourage everybody, but we totally understand that it's not achievable to everybody, and that's on us. It's up to us to actually simplify the self-hosted node as much as possible. But that is sort of the goal where we want to steer everybody to go, and we want to enable everybody to be able to understand enough about the Lightning Network without investing thousands of hours, so that you can essentially take on ownership of your own node, and you can run that. Of course, that is also sort of the order of complexity versus usability. So as so often it's a spectrum, and you as a user make sure to be informed about the trade-offs and choose what profile works best for you. If we're not happy with it, that's our fault because we haven't made it as easy as it should be. Excellent. I think I might have, let's say, 2 minutes for questions. Sorry, I went a bit over.
thanks for the talk. If I may be so bold as to ask if you have a recommendation for a Lightning wallet for your cell phone.
Lightning wallet for your cell phone. Well, I can only recommend what I'm using, which is Core Lightning Node. Oh, surprise! I'm one of the implementers of Core Lightning, and either the Zeus wallet or the Spark wallet. They both are very simple, very minimalistic, and sort of don't burden people with too many details of what the underlying technology. Again, going with the topic of abstracting complexity away from users and hopefully enabling more users to make use of it.
I
think there, yeah.
Is it realistic?
Oh yeah.
Sorry. Thanks a lot. I'm just wondering, like, what's your view on RGB and having like token on Lightning, like stablecoin?
It's definitely not something that I think I'm going to be using, but I so like the technology. Again, I started with Bitcoin in 2009, stumbled over this tiny paper, got hooked, made it my hobby. Now I'm working on it full time. So the technology is really, really cool, and I do know a lot of people are asking for it. It's just not something that I'm personally too involved, and I don't even know that I would have too much insights on how it would end up working. But I do think that hey, this is permissionless innovation, right? You want to build something, you want to do something that is really, really cool. Go for it, and you will succeed. I actually had discussions with Maxime, one of the RGB implementers, to get Core Lightning to implement RGB as well. It turns out that our plugin infrastructure wasn't flexible enough to actually let them do it without having to change Core Lightning itself. Otherwise, I would have loved to see RGB directly in Core Lightning. I think we had one here, yeah.
Okay, so within the next few years, our mobile phones will probably have 1 terabyte of data storage. Do you know if there are apps planned to have the blockchain on the mobile phone, and also maybe a Lightning app that would also enable channel management, what many would use a Raspberry Pi 4 for today?
So the I mean, storage has never been much of the big blocker for running stuff on a mobile phone. It's just a fundamentally different trade-off between having a hardwired connection to the internet, or be roaming using cell phone towers and having a mobile phone. So for me, as a protocol developer and as an app developer, things like latency and bandwidth to get to that mobile device is much more important and interesting. And there's not that much we can do. I know 5G promised infinite bandwidth and 0 round trip times, but maybe Starlink will do it, or even geostationary satellites, which are even further away. But so it's mostly that what is holding back mobile phones. Also, mobile phones are really picky about what they let you run in the background, because it's batteries, right? And I guess nobody is really happy with batteries draining really quickly. So having processes running in the background, really bad for battery life. And at that point, you might as well plug it in the wall and leave it there. But why not have a real machine then? I'm very much a fan of the Raspberry Pi model and remoting into a dedicated system, by the way, simply because that is always on. That can, even if your phone battery dies, it can react to stuff that happens on the network, and the availability of such a node is just way better than anything that runs on a mobile phone. But that's my personal opinion.
How do you feel about smart contracts on Lightning Network?
Smart contracts on the Lightning Network. Well, depends on how widely you define smart contracts. Off-chain protocols themselves are pretty much a smart contract. Or at least I keep calling them as such. It is a way to set up conditions, penalties, and collaborative settlements, which to me very much sounds like contracts. There's a limit to how complex we can go with these contracts, but we're continually finding new venues where we can add more features, where we can add new stuff. And don't forget, we do have a couple of networks that are very open to innovation, such as, and I know I'm going to plug Blockstream, Liquid's network. So
we are networking here.
Yeah. Okay.
Now we have a common code.
And
it doesn't matter which firm we are.
Yeah. So essentially, we have quite some leeway on how complex we can go on the Bitcoin mainnet. Meanwhile, we are also experimenting with things like covenants and more advanced scripting languages such as Simplicity on sidechains. One of the origins for the Liquid sidechain was actually to be an experimental platform for things that we want to eventually build into Bitcoin, but need more verification that it actually works and that it is safe. And one example of this was, for example, the SegWit deployment, which was first tested on the Liquid sidechain. And from what we learned, then we reworked the SegWit proposal to be what it is today. So quite a few venues where we can do stuff. Will we get a generic Turing complete thing anytime soon? I'm not sure, but
Basically, that's what I was asking.
Yes. So in my mind, Turing completeness is, and I probably need to keep that short, but it's okay. So Turing completeness in my mind is very much a red herring, because what we want to do is not have everybody essentially compute the nth prime number from scratch, right? What we want to do, what we want to do is be able to prove to somebody that the nth number is X, because I, as the prover, am the one who essentially makes a claim, and I then give you a proof that everything was handled correctly. And for that, you don't need Turing completeness. So there is, and I'm going to butcher this explanation, but Russell O'Connor will be much better at giving it. There's a weaker completeness than Turing completeness, called given by the Post theorem, which essentially tells you that in a non-Turing complete language where you have a finite representation of a proof, you can essentially prove anything that is computable in a Turing complete language. So very much like we do with signatures in the Bitcoin network, we don't want to give everybody the opportunity when verifying to create a signature. We want him to be able to verify that signature. So I, as a signer, will create a signature, and my goal is not to have everybody here also create a signature, because, well, that would be undermining the security of Bitcoin itself, but I want to give you just enough information that you can verify that what I did is correct. And that doesn't require Turing completeness. And I think that's sort of the right trade-off, where we can say, okay, look, we can prove arbitrary things to anybody in this room without having them actually do the work of coming up from it from scratch. So I think that might be a better view, and that's exactly where simplicity fits in, because simplicity is a language that implements just that subset, allowing you to make arbitrary statements and prove them.
Sorry. So speaking of Turing completeness, since you brought it up, and I apologize for daring to touch the interface with shitcoinery. What do you think is the technical outlook for using things such as DLCs to interface Lightning channels with, let's say, EVM chains, for example?
Definitely great possibility. I'm not too familiar with the EVM chain, so pardon me if
but without the, I mean, I guess I don't want you to touch on EVM chains per se, but just the idea that effectively in a DLC, I guess two parties can choose what their quote unquote oracle is of truth, right? Yeah. And that can be potentially even something published on some other blockchain, effectively.
Absolutely. Usually the issue that we have with this kind of smart contract is exactly the interface with reality, right? So with DLCs, what the ability that we get from it is essentially that we can make statements that are corroborated by an oracle and have other things depend on it, right? The classical example is betting on the outcome of the Super Bowl. So the Bitcoin blockchain can't watch the Super Bowl in real time. Too bad. It's missing a lot of good ads. Yeah, maybe the blockchain should have favored the brave too. So essentially what we do is we have arbitrary statements that are corroborated by an oracle on which we can depend our payments. Now, when I say there's limits to what we do, see that I always refer this to a payment, right? Because the Bitcoin blockchain in and of itself is mostly a value transfer network, and we don't have generic assets, we don't have NFTs and similar stuff. So you can essentially do anything that you can do with money, but you probably can't compute prime numbers on the blockchain.
Right.
Which some people might want to do. I don't know.
But in principle, I mean, obviously, like you said, you can't be like moving other types of assets, obviously. But like in principle, you could like a counterparty of yours that, for example, lives on some other some other chain could effectively come to agreement with you to have like your funds represent something on that chain on your behalf.
Yeah. So that very much boils down to RGB and Taro. Then again, where you can have coins represent assets that are actually outside of the Bitcoin ecosystem, but then you need intermediaries that are essentially holding those external assets on your behalf. And they need to be trusted in as such that if I buy a ton of copper, I better be sure that ton of copper is actually in somebody's cellar and that I could get it if I wanted to. Otherwise, it turns into a game of hot potato of trying to offboard that token as quickly as possible because there's no value behind it, right?
But wait, it could be done even sorry,
we probably should take that offline. Yeah.
Given that El Salvador is like the largest production Lightning rollout that we've seen to date, what are some of the things that you might have learned from that deployment or seen happen in the last few months?
States can't be trusted to choose your technology.
First of all.
So the rollout was very interesting. I was really scared of it because, hey, this network is my baby. I've been working on it for the last 7 years. Don't screw it up for me. And for all of the sort of anxiety that we had before, the rollout was really, really good and smooth. But there were a couple of issues, right? For example, the point of sales. Was it the Chivo app would sometimes show unsuccessful payments as successful and the other way around. And it was really strange that none of the companies that are actually involved in the specifications were involved in the rollout of Lightning. And the sort of the complexity only grew through confusion that was created by sort of signals that weren't as clear. All of that criticism aside, it seems to be working, and I'm really happy that we have a large-scale exercise of how things could look like, and I'm hoping that this kind of adoption will continue, and that El Salvador has a healthy Bitcoiner community that continues to use Bitcoin for their everyday lives, because that's ultimately our goal, right? We want to make everybody's life more comfortable, safer, and overall easier. If we haven't gotten that, we might as well not try. I think maybe one last question. Yes. Oh wait, you yeah.
Okay, so of Liquid, and we did, we're a big fan of simplicity. I did the first review for it. But the problem is that most of the web uses this thing called WebAssembly and Rust, and it's just where, for better or for worse, crypto's going. Do you think there's any chance that we could get Liquid or some sort of contracting language using WebAssembly or formally verified subset of which exist into Liquid at any point? Because I think that would actually really kind of help deal with the competition from Ethereum and other chains.
Yeah. Look, simplicity is essentially the assembler language that we are building the security guarantees on top of, right? It might not be the language that you actually write contracts in the end. So while it is true that that simplicity is a very clean and very nice construction of how we can build proofs and contracts that have a considerable complexity in them, it's definitely not the language I want to write myself. So things like having a front end, compiler front end that compiles down to simplicity is definitely something that is in the works. There is also a mechanism that allows you to essentially replace lengthy pieces of inefficient but safe code with so-called jets, aka re-implementations of known good primitives, such as SHA-256 and ECDSA. And those can be written in any language you want. If I'm not sure what the plans are with regards to WebAssembly, but an interpreter built in WebAssembly for simplicity is definitely a possibility, and that would be nicely portable as well. So think of simplicity as the EVM language. Who writes that nowadays? They're all writing Solidity or whatever the newfangled version of smart contract language is, without the solid academic underpinning that simplicity has. And that's the main contribution that we have. It's not we want you to write simplicity, we want you to write something that translates into simplicity so that we can show that it is safe. And now the very last question, because I skipped you before.
Very last question. I'm not so familiar with Liquid, but I'm wondering, just to raise my understanding, is it like an alternative to Lightning? Is it like a competitor, like Visa, MasterCard of Bitcoin, or what is your view on it, on the Liquid?
It's different. So the idea of sidechains predates these off-chain protocols where we essentially collaboratively manage a set of funds. The differences are that, yes, we essentially have a peg that moves coins from one chain to another sidechain. That is very similar to, hey, we lock in some funds and then we have to manage that collectively. The difference is that for Liquid, for example, there is only one instance, right? There is only one Bitcoin mainnet. There is only one Liquid sidechain. And with Lightning, you have arbitrarily many channels. There is no sort of joining the network or leaving the network. You essentially just have to find a counterparty with whom you want to open a channel, and you're in. Whereas sidechains usually have a bit more control over moving funds in and out of this other chain. And Liquid very much extends the Bitcoin scripting language and some of the features that are in Bitcoin itself, in the hopes of experimenting with it and offering complementary services to Bitcoin, but not really to Lightning as such. Depending on your interpretation, you might call them both layer 2 protocols, but honestly, I stopped counting layers because you can actually recombine them differently. We have, for example, a Lightning instance on the Liquid network. Do you call that layer 2.5? Because Liquid is layer 2. What do you call it? And you can flip layers around, by the way, too. So it's like, it's really weird. Stop numbering layers. Call them off-chain protocols, and we're done. Awesome. Thank you so much, and have a good continuation.